All right. So, uh, when you're building a high performance PC, like a gaming rig or something for content creation, one of the biggest things you have to think about
Oh, yeah?
is heat,
For sure.
right? You've got all this powerful hardware crammed into a relatively small space,
Absolutely.
and all those components, especially that CPU, are generating a ton of heat when they're working hard.
Yeah. You don't want your system to turn into a miniature furnace, right?
Exactly. Nobody wants a fried CPU or
Yeah.
swappling or any of that stuff.
Right.
So today, we're going to dive deep into the world of PC cooling.
I like it.
And specifically, we're going to compare two of the most popular options, liquid cooling and high-end air cooling.
It's a classic debate.
It is.
Yeah.
And honestly, there's no one-size-fits-all answer.
Right.
The best choice really depends on what you're trying to achieve with your build.
Absolutely.
Your budget, your level of comfort with tinkering,
Hmm.
even aesthetics can play a role.
For sure. Some people just love that look of a liquid-cooled system.
Oh yeah, with the tubes and the glowing coolant, it's like a work of art.
It can be, but we'll get into all that later.
We will. But first, let's make sure we're all on the same page
Good idea.
about how these different cooling methods actually work.
Okay, so at the most basic level, both liquid cooling and air cooling have the same goal: to move heat away from your CPU.
Okay, makes sense.
Think of your CPU like a tiny little hot plate just cranking out heat,
Right.
and if it gets too hot, it can't run at its full potential.
Yeah, and it could even get damaged in extreme cases.
Absolutely. So we need a way to transfer that heat away from the CPU and dissipate it into the surrounding air.
Okay, so how does liquid cooling do that? It sounds kind of complicated.
It's actually not as complicated as you might think. Imagine a miniature version of a car's radiator system, but inside your PC.
Okay, interesting analogy.
So liquid cooling uses a special fluid, usually water-based, that circulates through a closed loop. This loop includes a pump that pushes the fluid, a block that sits on top of your CPU to absorb the heat, and a radiator with fans that release that heat into the air.
So it's like a continuous cycle of absorbing heat from the CPU,
Yeah.
transporting it away, and then releasing it outside the case.
Exactly. The liquid acts like a super efficient heat transporter.
Okay, that makes sense. Now, what about air cooling? How does that work?
Air cooling is a bit more straightforward. It relies on direct contact and good old-fashioned airflow.
Okay.
You have a big metal heatsink with lots of fins. Think of it like a giant metal sponge that sits on your CPU.
Gotcha.
The heat from the CPU travels into the heatsink, and then fans blow air across those fins to carry the heat away.
So one uses liquid to transport heat, and the other uses metal and air.
Yep, pretty much.
But why would you choose one over the other?
That's the million-dollar question, isn't it?
It is. Let's start with liquid cooling. I know a lot of people associate liquid cooling with those crazy custom builds with glowing tubes and all sorts of crazy designs.
Yeah, those custom loops definitely grab your attention.
They do. But are those the only option for liquid cooling?
Not at all. There's a simpler type of liquid cooling that's become really popular. All-in-one coolers, or AIOs for short.
AIOs, okay.
Yeah, they come pre-assembled with everything you need: the pump, the radiator, the fans, the coolant, all sealed up and ready to go.
So it's like the plug and play option for liquid cooling.
Exactly. And they're available in different sizes depending on how much cooling power you need.
So if you're not looking to build a crazy custom loop, an AIO could be a good option.
Definitely, especially if you're not super comfortable with tinkering and potentially having to troubleshoot leaks and stuff.
Right, because leaks are a concern with liquid cooling, aren't they?
They can be, yeah. Although modern components and manufacturing have made leaks much less common, the risk is still there.
So you have to be careful.
Yeah. Choose reputable brands, install everything carefully, and double-check your work.
Okay, good advice.
But going back to custom loops for a second, if you are looking for ultimate flexibility and want to cool multiple components like your graphics card or even your RAM,
Wow.
then custom loops are the way to go. That's where you get to pick and choose every component from the water blocks to the tubing and fittings.
I bet that's where things get really fun and probably a bit more challenging.
Oh yeah, for sure.
Okay, but let's back up a bit. What are the main reasons why someone would choose liquid cooling in the first place?
Performance is a big one,
Okay.
especially if you're pushing your CPU to its limits with overclocking. Liquid is just better at moving heat away from your components so you can run them hotter and faster without hitting those temperature limits that cause your PC to slow down.
So it's all about maximizing performance.
Exactly. And it's not just about raw speed. Liquid cooling can also be quieter than air cooling.
Really? How so?
Because liquid cooling is so efficient, the fans don't have to work as hard, which means less noise.
Ah, that makes sense.
Plus, the radiators are designed to spread the heat out over a larger area, which also contributes to quieter operation.
So you get better performance and a quieter system.
Yep, pretty much. And let's be honest, liquid cooling just looks cool.
It does. Especially with the rise of RGB lighting, you can really turn your PC into a showpiece.
Aesthetics are definitely a big factor for a lot of people.
They are. And I've also noticed that liquid cooling can be more space efficient. You can mount the radiator in different places within your case, which can free up space around the CPU socket.
That's a good point. Some air coolers can be quite bulky,
Oh, yeah.
which can make it difficult to install other components or even close your PC case properly. Liquid cooling can be a more elegant solution in those situations.
Oh, okay. So we've heard the good news about liquid cooling. What about the downsides? Let's be real here. There have to be some trade-offs.
Oh, yeah, for sure.
What should people be aware of before diving into the world of liquid cooling?
The first thing that usually comes to mind is the cost.
Ah, yeah. Budget is always a factor.
Liquid cooling, especially those custom loops, can be significantly more expensive than air cooling. Even the all-in-one coolers tend to be pricier than comparable air coolers.
So if you're on a tight budget, liquid cooling might not be the best option.
Right, it might be better to allocate those funds to other components, like a better GPU or more RAM.
Okay, and we talked about leaks earlier, but is there anything else in terms of potential downsides?
Maintenance is something to consider.
Okay.
With air cooling, you pretty much just need to keep the heatsink and fans dusted. But with liquid cooling, especially custom loops, you'll need to change the coolant periodically, check for leaks, and maybe even clean the components.
Ah, so it's a bit more involved.
It is. It's
Okay.
not a huge hassle, but it's something to keep in mind if you prefer a more set it and forget it approach.
Okay, so we've covered a lot of ground with liquid cooling.
Yeah.
Let's shift gears and explore the world of high-end air cooling. What makes these coolers different from the basic air coolers that often come bundled with CPUs?
High-end air coolers are all about maximizing performance within that traditional air cooling design.
Okay.
They use large heat sinks with multiple heat pipes to quickly draw heat away from the CPU.
Okay.
And they pair those heat sinks with high-quality fans that are designed for both maximum airflow and quieter operation.
So they're not messing around.
No, they're serious contenders when it comes to keeping your components cool.
What are some of the big names in high-end air cooling?
You'll hear names like Noctua Be Quiet, Deep Cool Cooler Master thrown around a lot.
Okay.
These brands have a reputation for building incredibly effective and reliable air coolers that can handle even the most demanding CPUs.
All right, so let's get down to brass tacks.
Mhm.
Why would someone choose high-end air cooling over liquid cooling? What are the main advantages?
Well, cost effectiveness is a big one.
Okay.
You can get near liquid cooling performance for a fraction of the price.
That's appealing.
It is. This makes high-end air coolers a really attractive option for budget-conscious builders or those who just don't need the absolute bleeding edge of cooling power.
And I imagine the simplicity and reliability are big selling points too.
Absolutely. Air coolers have fewer moving parts, which means less can go wrong.
Right.
And of course, there's no risk of leaks whatsoever. Installation is usually a breeze too, often just a matter of clipping or screwing the cooler into place.
So less worry, less hassle, less to potentially break.
Yep, and maintenance is super easy too. You pretty much just need to keep them dusted and maybe replace the fans after a few years. No coolant changes, no leak checks, no fuss.
That does sound pretty appealing. But let's be honest, there must be some downsides to air cooling, right? What are the compromises?
Well, the most obvious one is size.
Yeah, those things can get pretty big.
High-end air coolers can be absolute units, especially the dual tower designs with 2 sets of fins.
I've seen them.
They can be challenging to fit into smaller cases, and they might even interfere with other components on your motherboard, like your RAM or your PCIe slots.
Yeah, I've had my fair share of battles with those massive heat sinks.
I hear you. And let's face it, air coolers don't quite have the same visual wow factor as liquid cooling.
That's true. They tend to have a more utilitarian look.
Right, but some manufacturers are starting to offer more stylish designs with all-black finishes or even customizable RGB lighting, so aesthetics are becoming less of a differentiator.
It's good to have options.
Yeah.
Anything else people should consider?
Noise can be a factor. While high-end air coolers usually use very quiet fans, they might have to spin faster under heavy load, which can lead to some noticeable noise. It's not always a deal breaker, but it's something to keep in mind, especially if you're sensitive to noise.
So you might be trading a bit of silence for that simplicity and cost effectiveness. It's
Okay.
all about finding the right balance for your needs.
Exactly. And finally, there's the question of thermal limits. While high-end air coolers can handle most CPUs without breaking a sweat, they might not be the best choice for extreme overclocking scenarios where you're really pushing your hardware to the limit.
So if you're a serious overclocker, liquid cooling might still be the way to go.
Probably, yeah.
Yeah.
In those extreme cases, liquid cooling just has a higher ceiling in terms of how much heat it can dissipate.
All right, we've covered the pros and cons of both liquid cooling and high-end air cooling. Now let's get to the heart of the matter. Performance. How do these cooling solutions actually stack up against each other in real-world tests?
That's where things get really interesting. Let's dive into some benchmark results and see how these coolers perform under pressure.
I'm ready for some numbers. What kind of tests are we looking at?
We've got some data from Gamers Nexus. It's a reputable source for PC hardware reviews and benchmarks.
Okay, I trust them.
Yeah, they do good work. So they tested a bunch of different coolers on an Intel Core i9-12900K CPU, which is known for running hot.
Yeah, the 12900K is a beast.
It is, and it really puts cooling solutions to the test.
Yeah.
They ran a Cinebench R23 stress test, which pushes the CPU to its limits for a sustained period of time.
Okay, so this is a good way to see how these coolers perform under real-world high-demand conditions.
Exactly. They measured both CPU temperatures and noise levels during the test.
All right, give us the juicy details. What were the results?
Okay, so first let's look at the liquid coolers. They tested the Corsair ICUE H150i Elite Capellix.
I've heard good things about that one.
Yeah, it's a popular choice. And they also tested the NZXT Kraken X73.
Another solid option.
Yep, both of these are 360 millimeter AIOs, which means they have a large radiator with 320 millimeter fans.
Okay, so plenty of surface area for dissipating heat.
Exactly. And for the air coolers, they tested the Noctua NHD15.
The classic.
Right. Noctua is known for their high-quality air coolers, and they also tested the Be Quiet Dark Rock Pro 4.
Another strong contender.
For sure. So let's start with the CPU temperatures. When the CPU was idle, meaning it wasn't under any significant load, all four coolers kept the temperature around the low 30s Celsius.
Okay, so pretty much the same across the board.
Yeah, but under load, things got more interesting. The liquid coolers, the Corsair and the NZXT, kept the CPU temperature around 75, 76 degrees Celsius.
That's pretty impressive. What about the air coolers?
The Noctua NHD15 and the Be Quiet Dark Rock Pro 4 weren't far behind, reaching 78, 80 degrees Celsius.
So just a few degrees hotter.
Yep. The liquid coolers had a slight edge, but the air coolers held their own.
Okay, interesting. What about the noise levels?
This is where things get a bit surprising. The high-end air coolers were actually quieter than the liquid coolers in this particular test.
Really?
Yeah, the Noctua NHD15 and the Be Quiet Dark Rock Pro 4 measured around 24-25 dBA, which is pretty darn quiet.
Yeah, it's barely a whisper.
Right, while the liquid coolers came in around 34-35 dBA.
So even though the liquid coolers were a bit better at keeping the CPU cool, they were actually louder.
It is, and it highlights that raw performance numbers don't tell the whole story.
True. There's more to consider than just how many degrees cooler your CPU runs.
Absolutely. Noise aesthetics, space, complexity maintenance, all of these factors play a role in choosing the right cooling solution for your needs.
Couldn't agree more. It's all about finding that perfect balance. And speaking of specific needs in our next part, we're going to get practical and talk about some real-world scenarios and how they might influence your cooling decisions. We'll look at specific coolers from both the liquid cooling and high-end air cooling camps, and we'll give you some real-world prices in INR to help you make an informed decision.
Sounds good. I'm ready to dive deeper. Okay, so in that last part, we were looking at some benchmarks, really putting those coolers through their paces.
Yeah, those numbers were pretty interesting. Like, I was surprised to see those high-end air coolers holding their own against the liquid coolers.
Yeah, they definitely can in a lot of cases.
Yeah.
Especially when you factor in things like noise and cost.
Right, exactly. So for this part of our deep dive, I thought we could get a bit more practical.
Okay, I like it.
Let's talk about some real-world scenarios and how they might influence your cooling decisions.
Let's do it.
Okay, so first scenario. You're a gamer, building a PC on a budget, but you still want to be able to play the latest games at decent settings.
Okay, yeah, that's a common situation.
It is. What's the cooling strategy here?
In that case, I'd probably recommend a high-end air cooler. You can get incredible performance for the money with coolers like the Noctua NHD15 or the Be Quiet Dark Rock Pro 4.
Yeah, those are both great options.
They can handle most modern gaming CPUs without breaking a sweat, and they're significantly more affordable than liquid cooling options.
So you get that sweet spot of performance and value.
Exactly. Plus, you avoid the potential headaches of liquid cooling like leaks and maintenance.
Right, exactly. Okay, next scenario. You're a content creator spending hours editing videos, rendering 3D models, or streaming your gameplay. What kind of cooling muscle do you need?
Content creation workloads can be really demanding on your CPU, so you definitely want a cooling solution that can keep up.
Yeah, for sure.
A high-end air cooler might still be sufficient, especially if you choose one with a larger heatsink and dual fans, like the ones we just mentioned.
Okay, but wouldn't liquid cooling be a safer bet for those really intensive tasks, like rendering complex 3D scenes or editing 4K video?
You're not wrong. If you're serious about maximizing performance and minimizing render times, liquid cooling is worth considering. Those few degrees cooler that you might get with a liquid cooler could actually translate into real-time savings when you're working on those demanding projects.
So it's a trade-off between budget and those performance gains.
Yeah, pretty much.
Okay, let's shift gears to a different type of user. You're a PC enthusiast who love to tinker, tweak, and push your hardware to the absolute limit.
Ah, the overclockers.
Overclocking is your game. What's the cooling plan?
If you're into overclocking, liquid cooling is pretty much a necessity
Really? Why is that?
because it's simply the best way to keep your CPU cool and stable when you're cranking up the clock speeds.
Yeah.
You're pushing the hardware beyond its intended limit, so you need a cooling system that can handle the extra heat.
So liquid cooling is the key to unlocking that extreme performance.
Exactly. It gives you that extra headroom to really push your hardware.
Okay, last scenario. You're building a compact PC, maybe a mini ITX build, and space is at a premium.
Ah, yes, the challenges of small form factor builds.
It's a whole different game.
It is. Space constraints can definitely make choosing a cooler tricky. Some high-end air coolers might not even fit in those smaller cases.
Yeah, I've run into that problem.
And even if they do, they can restrict airflow and make cable management a nightmare.
It's like trying to fit a square peg into a round hole.
Exactly. In these situations, liquid cooling can actually be a more elegant solution.
Really?
Yeah, you can often mount the radiator away from the CPU socket, which can free up valuable space and improve overall airflow within the case.
That makes a lot of sense. But what if you're not comfortable with a liquid cooling, or it's just not in the budget for this build?
There are some good air cooling options for small form factor builds.
Oh, good.
Yeah, several manufacturers make low-profile air coolers that are designed specifically for these types of builds.
Okay, cool.
They might not have the same raw cooling power as their larger counterparts, but they can still do a great job of keeping your CPU cool and quiet, even in a cramped space.
So there are solutions out there, even for those challenging space-constrained builds. I think these scenarios really highlight the fact that there's no one-size-fits-all answer when it comes to PC cooling.
I couldn't agree more. The best choice always depends on your individual needs, priorities, and the specific hardware you're using.
And it's not just about the practical considerations, right? There's also an emotional element to choosing a cooling solution. Some people just love the look of a liquid-cooled PC with those sleek tubes and glowing coolant.
Oh yeah, for sure. It's like a statement piece. It's like saying, hey, look at my awesome PC.
Exactly. And for some people, the peace of mind that comes with knowing their CPU is running cool and quiet is priceless.
Yeah, that sense of confidence is definitely worth something.
Absolutely. I think it's also worth noting that PC building is a journey.
Oh yeah, it definitely is.
You might start with a basic air cooler, and then as you learn more and your needs change, you might upgrade to a liquid cooling solution down the road.
Or you might stick with air cooling your entire PC building life and be perfectly content. There's no right or wrong path.
Exactly. The important thing is to do your research. Choose a solution that meets your needs and enjoy the process.
Well said.
Okay, so we've talked about these different scenarios and kind of the thought process behind choosing a cooler. But let's get specific now.
Okay, I'm ready.
Let's look at some real-world examples of coolers that you might be considering for your build. We'll start with liquid cooling options.
All right, let's dive in.
Okay, so first up we have the Corsair ICUE H150i Elite Capellix. This is a 360 millimeter AIO, which means it has a large radiator and 320 millimeter fans.
Yeah, this is a popular choice. It's known for its excellent cooling performance and its stylish design.
And it comes with Corsair's ICUE software, which lets you control the RGB lighting and fan speeds.
Yeah, you can really customize it to match your build.
Exactly. In terms of price, you're looking at around $18,000 to $20,000 for this one.
Okay, not bad.
Next, we have the NZXT Kraken X73. This is another 360 millimeter AIO that's very popular.
Yeah, NZXT makes some really nice coolers. They're known for their clean aesthetics and their easy-to-use software.
And the Kraken X73 is no exception. It has a beautiful infinity mirror design on the pump head, which looks amazing when it's lit up.
Oh yeah, it's definitely eye-catching.
Price-wise, it's in the same ballpark as the Corsair, around 18,000 to 20,000.
Okay, so both of these are premium AIOs.
They are. If you're looking for something a bit more affordable, we have the Cooler Master Liquid ML360R RGB.
Okay. Cooler Master makes some solid coolers at more budget-friendly prices.
This one is also a 360 millimeter AIO, but it's typically priced around 12,000 to 14,000.
So you're saving a few thousand rupees.
Exactly. And it still offers good cooling performance and customizable RGB lighting.
Not bad at all.
And finally, for those who are feeling really adventurous and want to go the custom loop route, we have to mention EKWB.
Oh yeah, EKWB is like the gold standard for custom water cooling components.
They are. They offer a wide range of water blocks, radiators, pumps, fittings, tubing, and coolants. You can literally build your dream custom loop with their stuff.
And they have some really nice pre-assembled kits too, if you don't want to go through the hassle of picking out every individual component.
Right, like the EK Kit Classic RGB P360.
Yeah, that's a good one. It includes everything you need to get started with a custom loop, and it has a sleek black and silver design with RGB lighting.
Very nice.
Yeah.
And in terms of cost, custom loops can vary widely in price depending on the components you choose.
Yeah, you could spend anywhere from 25,000 to 50,000 or even more on a high-end custom loop.
Definitely an investment.
It is. But for some people, it's worth it. They love the challenge, the customization, and the bragging rights that come with building a custom loop.
I can definitely see that. All right, so those are some popular liquid cooling options. Now let's move on to high-end air coolers.
Let's do it.
Okay, first up, we have the one and only Nongchua NHD15.
Ah, the legend.
This is a dual tower air cooler, which means it has two sets of cooling fins and 240 millimeter fans.
Yeah, it's a beast.
Yeah.
It's known for its incredible cooling performance and its whisper-quiet operation.
And it comes in two versions, the standard version, which has that classic beige and brown color scheme,
The Noctua colors.
and the Chromax Black edition, which has an all-black finish.
Nice for those who want a more stealthy look.
Yeah, exactly. Both versions are priced around 8,000 to 10,000.
Okay, so not cheap, but still much more affordable than most liquid coolers.
Right. Next, we have the Be Quiet Dark Rock Pro 4.
Another great option.
This is a single tower cooler, but it's still very large and capable. It has 7 heat pipes, a large heat sink, and 2 135 millimeter fans.
Yeah, be quiet. Coolers are known for their quiet operation, as their name suggests.
And the Dark Rock Pro 4 is no exception. It's one of the quietest high-end air coolers on the market.
Very nice.
And it's priced around 7,000 to 9,000.
Okay, so slightly cheaper than the Noctua.
If you're looking for something even more affordable, we have the Deep Cool Assassin III.
D-Cool makes some really good value-oriented coolers.
They do. This one is a dual tower cooler with 6 heat pipes, a massive heatsink, and 240 millimeter fans.
Wow, that's a lot of cooling power for the price.
It is, and it's priced around 5,000 to 7,000.
That's a steal.
And finally, we have the Cooler Master Air MA624 Stealth.
Okay, another Cooler Master option.
This one is a dual tower cooler with 6 heat pipes, a unique heatsink design, and 240 millimeter fans.
What's unique about the heatsink design?
It has a kind of staggered fin arrangement, which is supposed to improve airflow.
Interesting.
And it comes with an all-black finish for that stealthy look.
Yikes.
And it's priced around 6,000 to 8,000 down.
Okay, so right in the middle of the pack.
It is. So those are just a few examples of the many great liquid cooling and high-end air cooling solutions that are available on the market.
Yeah, there are tons of options out there.
It can be overwhelming.
It can. But hopefully this gives you a good starting point.
I think so too.
Yeah.
And in our next part, we're going to wrap things up by talking about the future of PC cooling.
Oh yeah, the fun stuff.
What kind of crazy new technologies are on the horizon? What's coming next?
I can't wait to dive into that.
Okay, so before we took a look at all those specific coolers, we were talking about the future of PC cooling.
Oh yeah, the future always gets me excited.
Me too.
So what are some of the emerging trends that have you particularly pumped? What kind of cool tech are researchers and engineers cooking up in their labs?
Well, one area that's getting a lot of attention these days is new materials.
Okay.
Scientists are always on the hunt for substances that can transfer heat even better than the copper and aluminum that are traditionally used in heat sinks.
So we're talking about materials that can pull heat away from the CPU even faster.
Exactly. And some of the contenders are pretty exotic.
Oh yeah, like what?
Well, we're talking about things like graphene.
Graphene. That sounds familiar. Isn't that supposed to be like super material with all sorts of amazing properties?
It is. It's incredibly strong, flexible, and conducts electricity extremely well.
Oh, okay.
And it turns out it's also fantastic at transferring heat.
So could we see graphene heat sinks in the future?
Potentially, yeah. It's still early days, but some companies are already experimenting with incorporating graphene into their cooling solutions.
That would be pretty wild. What other materials are in the running?
Well, carbon nanotubes are another possibility. Carbon nanotubes.
Yeah, imagine tiny tubes made of carbon just a few nanometers in diameter. They have even better thermal conductivity than graphene.
Nanotubes. Okay.
Yeah.
We're definitely getting into the realm of sci-fi here. Are there any real-world applications for this stuff yet, or is it all just theoretical at this point?
Some companies are starting to use these materials in actual products. It's not widespread yet, but the potential is huge.
That's exciting. And it's not just about the materials themselves, right? It's also about how they're used.
Absolutely. 3D printing is opening up a whole new world of possibilities for heat sink design.
Oh, yeah. 3D printing. I've seen some crazy-looking heat sinks created with 3D printers. They look more like modern art sculptures than PC components.
They do. And that complexity isn't just for show. Those intricate shapes and structures are designed to maximize surface area and optimize airflow, which leads to better cooling performance.
So it's about combining those high-tech materials with cutting-edge manufacturing techniques to create these super efficient heat sinks.
Precisely. And of course, we can't forget about fans.
The humble.
Right. They might seem like a relatively simple component, but there's
Yeah.
some really interesting innovation happening in fan technology, too.
Okay, I'm all ears.
Yeah.
What kind of fantastic advancements are we talking about?
Well, one of the biggest areas of improvement is in bearings.
Bearings.
Yeah. Traditional fan bearings create friction, which leads to noise and wear and tear. But we're starting to see fans with magnetic levitation bearings.
Hold on, magnetic levitation.
Huh?
Like those futuristic trains that float above the tracks.
Exactly the same principle. These fans literally float on a magnetic field, which means virtually zero friction.
Wow.
This results in incredibly quiet operation, longer lifespan, and potentially even better performance.
That's wild. And I bet those magnetic bearings would make the fans much more resistant to dust and other contaminants too.
You got it. And it's not just about the bearings. Fan blade design is getting a lot of attention too. Some companies are taking inspiration from nature, specifically owl wings.
Owl wings. Okay, now that's just cool. What's so special about owl wings?
Well, owls are known for their silent flight rate. Turns out the shape and structure of their wings are incredibly efficient at moving air without creating turbulence. So fan manufacturers are now mimicking those designs to create quieter and more powerful fans.
Wow, who knew owls held the secret to better PC cooling? It's amazing how nature often provides the best solutions. Okay, so we've talked about new materials, 3D printing, and fancy fans. What about entirely new approaches to cooling?
Sure.
Anything truly radical on the horizon?
There are some really intriguing concepts being explored. One that I find particularly fascinating is magnetic cooling.
Magnetic cooling?
Yeah, it uses a magnetic field to control the temperature of a material,
Okay.
and it has the potential to be incredibly efficient and virtually silent.
I'm picturing some sort of sci-fi device that just zaps the heat away. Is that even remotely realistic for consumer PCs?
It's definitely still in the early stages, but there are companies actively working on prototypes. It's a technology to keep an eye on. Another area that's generating buzz is the use of nanofluids.
Nanofluids, okay. My brain is officially in overdrive. What are those?
These are special liquids with tiny particles suspended in them, particles just a few nanometers in size.
Okay.
And these nanoparticles significantly enhance the thermal properties of the fluid. They can transfer heat much more effectively than traditional coolants.
Interesting. So could this be the future of liquid cooling?
Potentially. Yeah, nanofluids could lead to some serious performance gains in liquid cooling systems.
It sounds like the future of PC cooling is full of exciting possibilities. It's
Yeah.
amazing to think about all the innovation happening in this space.
It is, and those are just a few examples. Who knows what other breakthroughs are just around the corner? We might see things like phase change cooling or even thermoelectric cooling becoming mainstream in the future.
Okay, I'm officially blown away.
All right.
It sounds like the future of PC cooling is going to be wild.
It certainly is. And it's a great reminder that the world of technology is constantly evolving. What seems impossible today might be commonplace tomorrow.
Well said. Well, I think we've reached the end of our deep dive into the world of PC cooling. Hopefully, we've given you a solid understanding of the current state of cooling technology and a glimpse into what the future might hold.
Absolutely. Whether you choose a classic air cooler, a sleek liquid cooler, or something even more exotic, we hope you enjoy the journey of building your dream PC.
Couldn't have said it better myself. Thanks for joining us on the deep dive. Until next time, stay cool.